Hello everyone, it's Sajjad, and today we're going to solve a new problem of Leetcode. So let's get into it. Longest valid parentheses. It's a hard problem. Given a string containing just the characters open parentheses and close parentheses, find the length of the longest valid well-formed parentheses substring. Well, in case of parentheses, there is only two rules. The number of open parentheses must match the number of closed parentheses, and from the other hand, there must not be a closed parentheses before an open parentheses has been opened before it. So, in this case, this is a valid substring. This is a valid substring, but you couldn't this part. But you couldn't add the last character to it because there's no open parentheses before it. And as an empty string doesn't have any valid substrings, the length would be 0, the length would be 2, and the length would be 4. Okay, so let's read the constraints. The length of the string is between 0 and 30,000, and each character in the string is either an open parentheses or a closed parentheses. We're going to solve this with a stack. So let's jump to a solution. To solve this problem, we are using a stack. And stack is the last item that is added to the stack, always goes on the top. And we could only access the last item. So if we pop it, the last item would be popped. Last in, first out. The algorithm would be like this. We traverse the initial string and each time we encounter an open parentheses, we add the index of that open parentheses to the stack. If we see a closed parentheses, we first pop the open parentheses corresponding to this closest open parentheses to this closed parentheses from top of the stack. Now, there's a possibility that the stack becomes empty. If the stack is empty, we push the current closing parentheses index on top of the stack. Just look at the top of the stack, not pop it this time, to figure out the length of the longest valid string created with this algorithm so far. And the current index minus the top of the stack would be this longest current valid parentheses, as I mentioned. But why? Because the stack always has the index of either the closest open parentheses to the current index, it's the LIFO property of the stack, or the index of the beginning of a new valid substring. Why? Because if the stack became empty, we don't have any other open parentheses that was not closed, we put the closing parentheses index on top of the stack. And we are popping each time the open parentheses is occurring based on the closing parentheses. So this, we assure that no open parentheses is in the stack without a closing one, at least up until now, if the closing parentheses was seen. Now, if the length that we have found is greater than the ultimate length that we found for the longest valid parentheses, this is the new maximum. Let's see it on a real example. So right now, the maximum length of a valid parentheses is 0. Now, for the sake of consistency, we first put a -1 on the bottom of the stack. That way, we are indicating that we are starting from before the array even starts. So we start the iteration. We are at the 0th index, and at the 0th index, it's an open parentheses. So we push it to the stack, the index of it. We go one step forward. Now we see another open parentheses. We have to push it to the stack, and we do. Then we go one step forward. Now, for the first time, we're seeing a closed parentheses. So our algorithm said, if it's a closed parentheses, we first pop one item from the stack, which we did. Then we get the top of the stack, which is now 0. And we create a difference between the current index minus the top of the stack, which would be 2 minus 0. And it makes sense because starting from 0, 1 and 2 is a valid parenthesis ending at 2. That's the longest valid parenthesis ending at 2. That's 2. Now we check if the longest valid parenthesis is greater than the ultimate valid parenthesis that we had, then we just update the value of it. Now the maximum 0 was less than 2, the new maximum would be 2. Okay, we go one step further. It's an open parenthesis, add it to the stack, 3. It's a closed parenthesis. Again, first pop one item from the stack. Check the top, it's 0 again. See, 1 open, 2 close, 3 open, 4 close. Now, the longest valid parentheses up until the index 4 is 4 minus 0, which would be 4. Okay, now we go one step further. It's another closing parenthesis. We pop one item from the stack. We check the top. It's minus 1. So the longest current parentheses ending at 5 actually started before the stack before our iteration started, the minus 1 that we initially put in there. So 5 minus minus 1 creates 6. Now we check, is 6 greater than the maximum that we have, which is 4? Yes. So we put this current maximum ending at 5 as the ultimate maximum, which would be 6. We move forward. It's a closing parenthesis. We pop the item from the stack, as the algorithm says. But this is for the first time happening. If the stack is empty, we put the current index there. What happened? 6 is closing. We don't have anything on the stack, meaning we don't have any possible type of valid parentheses starting that would happen before 6. So 6 is the first place that could happen. We put it on the stack. Now we go for 7. Index 7 has an open parenthesis. We just add it. We go to the last index, would be 8, which is a closed parenthesis. We pop one from the stack, check the top, it's 6. We do a calculation. 8 minus 6 is the longest parenthesis. Yes, makes sense. And it's 2. But is it more than the ultimate maximum that we had, which was 6? No. So we don't update it. We go one step further. The string itself is finished. And now we don't have any more items to process. And the ultimate maximum that we found is 6. It was starting from 0, ending to 5. It's a valid string of parentheses with 2 nested parentheses inside. So let's code and see how it would be in code. As we see, we have the string s passed to the function called longest valid parameter parentheses. This is what we decided that the algorithm should be look like. Let maximum length be equal to 0 at the beginning. Now we need the stack as well, which is an array of numbers initially filled with -1, right? We iterate over the entire string from index 0 until the place that there is no more items on the list to go through. Now we have 2 scenarios. Oh, by the way, at the end we are sure that we are returning the maximum length as the result. If the s of I is an open parenthesis, what was our strategy? We just pushed it at the top of the stack, so it's just being pushed. But what are we pushing? The index, yes. And we don't want any other part of the iteration or the loop to be executed, so we just continue it. Now, when we're here at line 11, we are sure that the character on SI is a close parenthesis. So if, so we first pop it, an item from the stack. Now we check if the stack dot length equals 0, meaning the stack right now is empty. We are pushing the current index on top of the stack. Stack dot push equals the current index. Last but not least, we want a top, right? So let top be stack dot length -1, meaning the last item of the stack. Now, the maximum length is actually the maximum of top of I minus top and the previous maximum length. We run the code and see what it gives for its internal test cases. Okay, we have a typo. Length. Yeah. We run it again. It passes for its first test case. Let's test it with all the test data that we have. Now let's submit it and wait for the results. Yes, it's a success. Thanks for watching this video. If you're interested in Leetcode and problem solving in general, well, don't mind to check out my other videos on this topic. And if you have a suggestion or a problem for me to solve, please add it to the comment section below. Don't forget to subscribe. That would help me a lot. And until the next one, see you. Bye.